Hello friends, welcome back to my channel Engineering Chronicles of Plant Design. So we are continuing with pressure vessel design as per ASM section division 1, and in today's video we are going to see a lot of what selection of flange, and we'll also see an example and what are the effects of external loading on a flange, how to select a flange when there is an external loading, what are external loading, what are the factors, and what are the openings required in a pressure vessel based on ID. So all these things are going to see in today's video. Okay, so let's move ahead. So the first slides which I have put is about selection of flange. So if you see my previous video, which is the basic of piping, you can find that there are different classes of flange, right? 150 class, 300 class, 400, 600, 900, 1500 and 2500 rating. This classes is a actually it's a dimensionless number, and these are actually, to be precise, it is a pressure and temperature ratings, you know. And this rating, you can see this rating which is defined in ASMA 16.5 table through 2-1.1 to 2-3.19 depending upon the different material applicable, and it is also mentioned in section 2. If you go in section 2, even there it is there, you'll have different tables over there also, okay, for flanges. And to select this flange, okay, there is also mandatory appendix 2 list pressure temperature rating using PSI units for pressure and temperature degrees Fahrenheit. So it is in mandatory appendix 2 also there is that they have listed PT ratings, okay, and they have put in PSI and Fahrenheit, but this we can also do in bar and degree centigrade. In 16.5 we have a table for that also. Okay, for high temperature application, in high temperature application to creep range will result in decreasing bolt loads, relaxation of flanges bolt and gasket takes place. So for what happened in a high temperature, the load on the bolt, right, which becomes higher, and that is the reason why when we go for a higher class, when we go for a higher class rating, 300, 400, 500 class. So what happened? Sorry, 300, 400, 600 class. What happened? The number of bolt size will go on increasing. Thickness of the flange will go on increasing. So what will happen? This it takes the bolt take the maximum load. That is the reason why we go for a higher class when there is a high temperature application. The flange joint might leak due to reduce the load sustained capacity of flange. This has happened due to decreased bolt load. Okay, so what will happen when the bolt load decreases in the high temperature rating? It will definitely start leaking from the joint. Okay, as I said, for that reason we go for a high class flange rating. For low temperature application, carbon steel may undergo a decrease in ductility. So here we will see in the further video, we will see about impact testing. What is the factors governing impact testing and why impact testing is very important depending upon the conditions. So what will happen in low temperature? The carbon steel material will become ductile. That means it will become brittle, and it may cause cracking. Cracking may occur. Okay, and sudden change in the pressure and the temperature, it will not sustain the shock. Okay, so impact testing is important over here also, and we will see that in the later part of the video. So let's move ahead with the example with the external load. What will happen when there is external load in the flange? So what will happen? Okay, so due to if you see this is a flange, this is a flange. Okay, this G is what we call as effective gasket diameter. G is the effective gasket diameter. Normally, the ID. Okay, this effective gasket diameter means the gasket will be having OD and ID, correct? So effective normally we take at the in the intermediate range, or because here in the center there will be a lot of pressure exerted due to the bolt. So we'll take effective gasket diameter, and there are three different external load, which we call moment M1, M2, because see, X, this is X axis, this is Z axis, this is Y axis. Okay, so in these two axes we'll be having moment due to external load, and this in the X axis will only be having external axial force. So what will happen due to the pull over here, you will have axial force, correct? And because of the external pipe which you connect over here, you will face moment at these two axes. So this is called external load, and this is normally defined by the by the not by the manufacturer, by the vendor, by the client, because client has to specify or by the piping team. So piping team will specify that at this particular flange in this particular pressure vessel there will be this much of external load acting. So what will happen in this case? Your pressure, total pressure will change depending upon the external load. Okay, determining the resulting moment. First, what we do, we'll find M resultant. The formula is root of m1 square plus m2 square based on this m1 m2. Then we'll determine the moment due to the resultant moment. Sorry, due to the pressure due to the moment. So that will be Pm. It will, the formula is 16 multiplied by m resultant divided by pi into g cube. So g is the effective gasket diameter. Okay, and determine the pressure due to force. So due to Fax, that is axial force, that will be pressure. Okay, now once we determine Pm and Pr, so the pressure rating will change. So your pressure on the external due to external load on the flange is will be equal to Pt is equal to Pi plus Pm plus Pr. So Pi is the internal pressure, Pm is the pressure due to the moment, Pi is the pressure due to axial force. Okay, so based on this only we will be doing the flange selection. Let's take an example. So here I have taken an example. The required pressure is 10.5 bar G and temperature is 220 degrees centigrade. Okay, and the flange rate is SA105. Consider external load to be negligible. So what we have considered external load to be negligible. In that case, what we'll do? Pi is equal to Pt is equal to 10.5 bar. So we know grade flash grade is SA105, SA105 or A105. SA is a ASTM grade and A105 is the ASME section division 1 material grade. So we'll go to 16.5 table 1A list of material. So we will check what is the in which table will this material fit. That is A105 will fit. So here if you see list of material, okay, this is table 1A, the forging this forging material 105. So see carbon and silicon matlab carbon steel, the material group is 1.1 and pressure temperature rating table will be 2-1.1. This is first table. Okay, in the 16.5 this is first table. Okay, so we determine in which table we have to go. So now what we will do, we will go to this table 2-1.1, correct. So in 2-1.1 table, 2-1.1 pressure table, so we will again find our material over here A-105. This table is also applicable for casting material A-216 grade WCB1 and A515 grade 71, A515 grade 70, 12, A515 CR. This 1, 2, 1, 4 in bracket is all notes, and you will find note over here also. Okay. So first what we will do, we will define our we will check. Let us check 150 class. So our temperature is 210 degrees centigrade, right? So we will here we have 250 degrees centigrade in table. We can also interpolate, huh? We can interpolate and find that at that particular pressure temperature, what will be the maximum pressure. That also we can define. But what I have done is I have not done that. I have not done interpolation. I have taken maximum temperature to 250 degrees centigrade and pressure at 150 class is 12.1 bar. Okay, so design pressure is how much? 10.5 bar at 210 degrees centigrade. So we conclude that 150 class is acceptable as per pressure temperature rating. Okay, what if you want to find the exact temperature at 210 degrees centigrade, you need to interpolate between this and this factor. You will find the exact pressure rating at that particular temperature for the 150 class pressure 150 class rating flange of this particular material. Okay, so if you see note 1, we have find note 1 here. We need to see because here we have put note 1. So note 1 says upon prolonged exposure of temperature above 425 degrees centigrade, the carbide phase of steel may be converted to graphite, permissible but not recommended for prolonged use of 425 degrees centigrade. So in the year what it says that if your design temperature is 425 degrees centigrade for a prolonged, that means for a longer time or for a continuous period. So this particular material is not applicable. You need to go for the higher next for a high temperature rating material. Okay. So always, when there is a note put in next to material, go to notes and see what is written over here. Note 2 T4 is also same. Okay, so we our temperature is less 210 degrees centigrade, 210 degrees centigrade. So 425 is near to higher for our range. In that case, we can go for 150 class pressure flange. Okay, I hope you understood. If you have not understood, you can see the markings which I have done. I have put some I have put the details over it. That also you can see and you can understand again. Pause the video for some time, read it, understand it if you want to understand in further way. Okay. And next we will see inspection opening, that is UG46. So for every pressure vessel, ASME section at division 1 says that for every pressure vessel you need to have inspection openings. Okay. So they have given the details over here, UG46. If the process material inside the vessel is very corrosive, very corrosive, so in that case you can exempt the inspection opening. Okay, that you can exempt, but that should be defined by the client and your AI should approve it. Okay, that is one. Second is if the ID of the vessel is less than or equal to 12 inch, so you may omit the inspection opening with two or more pipe connection are present, permitting internal inspection when removed. That means, for example, you have two flange joint and two flange joint in the or you have one threaded joint. So that means what will happen when you remove this flange joint, you can inspect from that particular flange joint, right? So in that case, you can omit the inspection opening. That is what this statement says. If your vessel ID is more than 12 inch and less than equal to 18 inch, in that case you need to have two hand holes. You need to have two handles. Like this is compulsory now. So after 12 inch, it was not compulsory, but if it is more than 12 and less than 18, here if you it is mandatory to have two handles, and the size of handle is 14 NB, that is 1.5 inch. Okay, so you need to have two handles, so the person can go and inspect from that particular handhole that everything is inside, everything is okay or not. If okay, so if the vessel ID is more than 18 inch to 36 inch, okay, inclusive, so then what will happen here, it is mandatory to have a manhole or two handhole or threaded opening. Okay, but here if it is 18 to 36 inch, you need to have one manhole. Okay, and above 36 inch ID, it is mandatory to have manhole. Here you cannot have two handhole opening and say I provided two handhole, I will not provide manhole. No, above 36 inch ID, it is mandatory to have a manhole. And when the inspection openings are required, they must meet the following: electrical manhole shall not exceed 12 inch by 16 inch. Circular manhole shall not less than 16 inch. That means if you provide a manhole, it should not be less than 16 inch. It should be more than 16 inch. A handhole shall be less than 2 inch by 3 inch. Okay, these are the conditions which we have given for openings, and this is very important because whenever the AI will see all these points in your design, whether you have provided proper manhole or proper handholes, inspection openings you have provided or not, because these are mandatory requirement. Okay, so moving next, you see this is a flange in a vessel. This is a vessel shell, and this is reinforcement. This is the neck of the nozzle, and this is flange. Here they have used WNRF flange, that is well neck race face. Here you can see a race face over here. Okay, so here there is a vent to release fumes. So what is the vent? So what will happen when you have a flange? When you have a reinforcement pad, RF pad. So RF pad, when you weld here, what will happen? In between the shell and the reinforcement pad, there will be too much of fumes getting accumulated. And what will do? This fume will try to escape from the weld, then it will try to escape from the weld joint. Because when you start welding, the weld is very creep or very ductile, because it is very hot in nature, right? So this fume can damage the weld and it will crack the weld. So to avoid that, we always provide vent, a small vent, that is 6 mm or 3 mm, okay, not more than 6 mm. We provide a vent to release all the fumes. Okay, and this later you can sometime we can leave it, and we can sometime we plug it or something. It depends upon the client. You say you need to plug because the external conditions are not so good. So in that case, you can plug again, but you need to provide vent during the welding of this reinforcement pad. Okay, so now why reinforcement pad is required? Reinforcement pads are not mandatory. It depends upon the size of nozzle, how much size is required, and there is also one factor which is called area replacement factor. So we may see the area replacement in next video, but we will see what are the exemptions to avoid reinforcement pad. So before that, I put a slide which is called design of opening. So design of opening means when you put a opening in a shell or in a head or in any pressure vessel, any part. So that case you need to follow some criteria to design the opening. Okay, the opening shall preferably be round, elliptical, or oblong. So all three is possible. The basic approach of the opening reinforcement rule division 1 follow an area replacement method. I said earlier. We will see in a detailed video about the area replacement. This method required the area of material removed to be replaced along the edge of the opening within a calculated distance limit proportional to opening. This also we will see in a area replacement video. What is the meaning of this sentence? We will we'll see a detailed video about it. So small opening are exempt from reinforcement UG36C3. This we will see next slide. What is UG36C3 and what are the exemptions we will see. Large opening we will see next video. We will not cover over here because too much is you need to there should be some limit to the video. I cannot put all the detail in one video, right? So we'll see next video. For opening under external pressure, opening of an opening in a flat head or cover, 1.5 of the area removed for the opening must be replaced. This again here is fall into area replacement factor only. This we will see in the next video. Unless a full penetration nozzle attached well detail is used, attachment well strength calculation must be performed. So what is the attachment well strength calculation here? If you see WRC bulletin as given 107297537. What is WRC? Everyone might be puzzled about what is WRC, right? WRC is Welding Regulation Council. So WRC have its own standard when you do a welding on a particular nozzle or with reinforcement. So you can some client, if you have external load or you have or uh, or if your client says no, I want to perform WRC calculation, in that case depending upon the type of weld, size of weld, and the type of the welding material used, WRC will be applicable in this 107 and based on that we will do the WRC calculation to define that the weld which we have performed on the pressure vessel is sufficient enough to take that load. Okay, this rules only consider pressure or pressure loading, but other load condition must also be considered. That we have seen already in the second slide, that is about the external load. What is the pressure? We have seen how the external load will impact on the pressure, and that pressure you need to consider. But in WRC calculation is different. I'll try to put a video separately on WRC calculation. Okay. So next is UG44B address nozzle flange load detail under external pressure. So under external pressure, what is the flange load? Flange load. So you can have to go to UG44B. Okay. So moving again, as I said, small opening exemptions. So for example, if you have a nozzle in a shell or a head, minimum thickness is less than or equal to 3 by 8 inch, which is nearly equal to 10 mm. Okay, and a finished opening diameter is less than equal to 3.5 inch, that is 89 or 90 mm. In this case, you can exempt the reinforcement pad or area replacement check. Okay, what I'm saying, just recollect again. If your thickness of the shell or head is less than equal to 3 by 8 inch, that is 10 mm, and finished opening diameter less than equal to 3 by half inch, that is 90 mm, then you can exempt reinforcement pad. But your client precise your pursuits to I want to still check the area replacement whether it is possible. Yes, you can still check and you can still confirm based on the area replacement formula. In shell or head having a minimum thickness, okay, of more than 3 by 8 inch, if your thickness is more than 3 by 8 inch and the finished open diameter is less than equal to 2 by 8 inch, in this case also you can exempt the reinforcement pad. We have seen less 10 mm, about 10 mm and more than 10 mm. So about 10 mm your opening has to be 3 by half inch, that is 90 mm, and your 2 by 3/8 inch, that is 65, nearly 65 70 mm. You can exempt RF pad. Okay, in both the cases you can exempt RF pad as per UG 36C3. For thread or studded connection, the finished opening diameter less than 3 by 3 inch for all shell thickness. So if you have a threaded or studded connection, the finished opening should not exceed 3 by 3/8 inch for all shell thickness. Uh, whatever be the shell thickness, the opening should not be more than 2 by 3/8 inch. Okay. So we'll move ahead. Additional rules for opening exempt from the reinforcement. So additional rules, what it says, for example, if you have two nozzles next to each other, so in this two nozzle should have some distance. Okay, so distance should be twice their average diameter. Twice their average diameter. Average diameter is not opening diameter, is not ID in a diameter, but average diameter is a diameter which we say NPS or NPS 14B, which we say, right. So for example, if you have 30-inch nozzle, so 30-inch nozzle OD is 33.4 mm something, and ID will change depending upon schedule, but your average diameter will be in between these two. That will be your average diameter. So the no two isolated unreinforcement opening shall have their center closer than twice average diameter. For example, if you have two nozzle less than two 3.5 inch, if your and the shell has thickness less than 10 mm, so they should both be separated with the two times diameter distance. For example, that is uh, that is 90 plus 90 is 180 mm. So they should be 180 mm apart, center to center. Other than, but okay, so in that case, you can also exempt the reinforcement. No pair of unreinforced opening in a cluster of three or more unreinforced openings shall have center closer to each other then. So for example, if you have unreinforced opening cluster in a shell in a head, to next to each other, in that case for cylindrical conical shells, this is the formula 1.1 plus 1.5 cos d plus into d1 plus d2. D is a some this theta is given. For example, just a minute. For example, this is your shell and you have a nozzle like this. Okay, this is a nozzle. This is a nozzle. Okay, so this angle defines theta. Understood? So this angle which we have here is called theta. And if theta is straight, it is which we have 90 degree. So what is cos 90? Cos 90 is 0. So here is d1 plus d2. That is this, again we follow the same sentence. Correct? So that is the reason why if there is a theta angle involved, so the factor is increased and you will have or decrease depending upon the this formula, and you will have a separate value. Okay. For spherical shell or form head or flat head, it is 2.5 d1 plus d2. This has to be the distance between the unreinforced nozzle. You have to also cross check this. In that case, because if you don't see, I have given angle between the common center line between the opening and the longitudinal axis for shell. Okay, that is exactly this theta. Okay, so this you have to confirm because your AI will confirm, or your AI or your inspector, the design engineer should confirm that whenever you have a two opening next to each other which is unreinforced, does this met this formula, have this met this formula, or has this met this formula. Okay, if it is not met this formula, then you have to again go for area replacement and you have to provide a small reinforcement pad. I hope you have understood, and stay tuned, and I will be putting more videos about the reinforcement pad and area replacement in the upcoming days. Okay, stay tuned and keep subscribing to my channel. I hope I'm giving you enough information. Thank you and have a nice day.